Hello, my name is Frank Lansner, and this is the It's Climate Science video series about global warming. This time we're going to talk about the positive feedbacks and water. Let's first take a look at the fundamental idea. It's a theory that supposedly makes CO2 dramatically more dangerous than if we had not these positive feedbacks. First we have CO2, that's the theory, and it causes some heat. I think most scientists agree that the heat directly caused by CO2 is not that dramatic. And as you say, we normally say that it's not the direct effect of CO2 that will cause disasters. No, the theory is that the heat provided by more CO2 in the atmosphere will cause more water in the atmosphere. Water is also a greenhouse gas, and then it becomes dangerous and we get even more heat. In fact, the positive feedback from the extra water is considered to be a larger contributor to heat than the direct effect of CO2. So, James Hansen from NASA 1984 writes about water vapor, that he considers it to be an important source of this feedback. He writes, water vapor provides the largest feedback, with most of it caused by the increase of water vapor amount. So, in 2007, in the IPCC report AR4, they mentioned the issue of water vapor feedback. They say, upper tropospheric concentrations, meaning the concentration we have around above 7 kilometers, up to 10 maybe higher, but this area, contribute disproportionately to the natural greenhouse effect, meaning that this is an extraordinary part of the greenhouse effect that actually comes from this area and from water vapor feedback. And they are so generous that they also offer an explanation. They say, and because lower down the atmosphere is nearly opaque at wavelengths of strong water vapor absorption, meaning that the water vapor at ground level or below 7 kilometers hardly has any effect, because there's already water vapor present in the atmosphere so much that all the frequencies are being blocked already. So it's only changes in water vapor up here that can make a change, and this is why they expect this area of the atmosphere to be very important. Now, so they say we need to look at more than approximately 7,000 meters altitude, this water we are looking for. So, let's take a look at the development of specific humidity, the water vapor in the atmosphere. Here we have from around 1950 up until today. And there's a lot of colors on all these graphs. Each graph represents one altitude, so it's one data set for one altitude of water vapor. What we can see is that these graphs normally they do not they do not say that today we have much more water vapor than we had in the 50s. But on the other hand, most graphs say that there's a slight increase in recent decades, although the 4 and 5 kilometers graphs almost are flat with no development. But of course we are most interested in these, the very high altitudes, because as IPCC said, this is where the change in water vapor is going to be important for the feedbacks. But the development of water vapor for 7 kilometers is certainly not increasing at all. And the same we can say about the 9.5 kilometers is decreasing, not increasing. At least we can say that for sure. And for 9.5 kilometers we see the same pattern, that water vapor has been decreasing since the 1950s. In fact, we can see there is a trend of decreasing water vapor concentrations exactly in the area important for the positive CO2 feedbacks via water vapor. Let's look at the data graph itself for 9 kilometers. You can see there's a lot of variation, but there is a steady fall from 1948 till today. And then there has been talk about that the first portion is not valid, the second portion is not valid, but it doesn't matter what portion you look of this graph, there is actually a falling trend pretty much in all periods. So, what does that mean? It does mean that it seems that something is wrong with the equation, because above the 7 kilometers there is not more water today than there was early on. So how can we have a positive feedback from CO2 via water when there is not any more water where it really counts above 7 kilometers? Is there some kind of alternative mechanism, or how does it work? How can you claim that there is a positive feedback without the support of an increasing water vapor concentration? As you know, in the climate debate, there are always two sides to any topic. And so far, it's almost too easy for me to say that the general theory about CO2 positive feedbacks has a problem because of water vapor feedbacks. What generally happens when you come in debates with these facts, these data? Normally you are met with a graph like this. Such graphs of the specific humidity in the atmosphere you can find on NOAA's website, you can find it on Open Mind, Termino website, and so on. And they simply say specific humidity anomaly, and they show graphs that are rising. After having digged into the data, I'm a bit surprised to see that, because it's certainly not what I saw in the data myself. Okay, we have 3 papers. They're all published around year 2007. It was around that time it became common knowledge that water vapor concentrations in the high troposphere and lower stratosphere was declining, and that the temperatures in the same area actually also were declining. And just around that time, a lot of papers came saying something else, including these. So how come we see the graphs saying that there is a specific humidity increase over the years from 1970 until almost today? Well, if you look in after the first paper, it says surface humidity. So when the graph says specific humidity, it turns out that they're probably talking about surface humidity, the humidity on the first like 200 meters or so above the ground in the air we breathe. And in the next paper, again, it's the surface humidity. So for some reason, 3 teams of scientists independently, I guess, have chosen to make papers on the water specific humidity, and they have chosen the same approach of using surface humidity only, and the same years, sort of. In one of these writings you can see the well-known scientist Phil Jones, that happens to appear in many papers that are crucial in context with the global warming debate. Now look at the black graph here. It goes like this and has this increase just like the other graphs. These 3 colored graphs are the 3 graphs you saw just before on the other slide. And now I have put them on top of the data that was already existing before these papers. So what you can see is that the 3 papers made around 2007, they all simply reproduce the black graph that was already known for the surface humidity, and they all have seemed to cut off some years and only look at the increase. And then on top of this, it seems that where I find these data, it is presented as atmospheric humidity rather than surface humidity. These are the data I showed you in the beginning. And you can see I have now colored with red dots the data chosen for all 3 papers, all 3 articles on this topic around 2007. And as you can see, they have all used just these data that show an increase in the water humidity and hardly has mentioned the rest of the data. Here is how the 3 articles looks on the NOAA webpage. Again, it just says specific humidity. It doesn't say specific surface humidity. And you can also wonder why would anybody be interested in just the surface humidity? For what purpose do we need that information? I have to say, if you then click on the articles, then you will see in the articles that it is surface humidity. So, Tamino from the Open Mind webpage on global warming says, one of the interesting graphs is multiple estimates of specific humidity, the amount of water vapor in the atmosphere. And he shows these 3 graphs that are only dealing with surface humidity. I would call that misleading. Phil Jones then, in his article, writes, the first rigorously homogenized and quality controlled global gridded 5 by 5 degrees monthly mean anomaly humidity data set in Q&R hue suitable for use in climate studies. And I just don't know where he's going with this, because a data set only looking at the first like 200 meters of atmosphere, the water humidity there, what kind of climate studies would use that ever? I mean, it doesn't even rain from that area. And I think Phil Jones should know that, that climate studies would need more than surface humidity. So I'm just speculating, why are they making these articles? Is this science? I guess we can say for sure that it is climate science. One of the authors to the article writes, the surface observation provide much better spatial and temporal sampling than radio sondes. So his point in his article on surface humidity is that there are much more stations at the surface than up in the air. Well, that's a good argument not to look at those data up in the air, isn't it? I don't know if that is his argument. I just like the sentence, nice sentence. So let's return to the original data set for the 9 kilometer water vapor concentrations, the specific atmospheric humidity in grams per kilo from around 1950 till today. We see this falling trend. Then I found another graph. It's not exactly the same area because this is global and this is the tropics, but the tropics is a huge area around the middle of the whole globe, and it's a data set collected from balloons, but this is temperatures. This is water vapor concentration and this is temperatures. It so happens that the warmer air is, the more water it can hold, and vice versa. If it gets colder, it cannot hold so much water. So it's not shocking if temperatures and water vapor concentration to some degree will follow each other. And can you see any resemblance here? If we put them on top of each other, it looks like a kind of agreement to me. I took this temperature data and put it on top of the water vapor data. So what we see is a very good fit with the temperature data from REAP Core Tropics and the global water vapor data from the same altitude. Practically, it's the upper troposphere or very lowest part of the stratosphere, around 9 kilometers. As we see, there is a decline in the water vapor concentrations, and I've seen arguments that the early years of these water vapor data from NOAA, they're no good. But the problem with this data set is, even though you remove this from the data set, you will still see a decline. So, and if you say, okay, we will remove this also, actually even in the last years there is a little decline. So whatever you do with these data, you're not going to see an increase in this area that where the water vapor was supposed to have increased if the CO2 positive feedback theory should be real in the real world. So instead, the scientist I've seen here and there seems to completely dismiss this data set completely. And I find that's rather interesting, because in this year here, 1969, humans were able to send a rocket to the moon with people, but we are not able to measure how much water there is in air. As you can see, the two graphs, the water vapor and the temperature, have some characteristics in common. They're both declining, at least not increasing. But let's check the adjustment then. Of course, we almost always have adjustment when data are not supporting the climate change viewpoints of the IPCC and others. The black graph here is actually the more original version of the REAPCOR balloon temperature series. It is the 1.2 version actually, and it is actually the red that is the 1.4 version. The red came later, and as you can see before, around 1985, they have lowered the values, made them more cold, and after 1985 they have added heat, made them more warm. So before the changes, there was a decline in this particular temperature data set, and after the changes there was an increase of temperatures over the years. That's all for now. It's climate science. Thank you.